Example on page 358, number 75, states, on a particular Labor Day, the high tide in Southern California occurs at 7:12 a.m. At that time, you measure the water at the end of the Santa Monica Pier to be 11 feet deep. At 1:24 p.m., it is low tide, and you measure the water to be only 7 feet deep. Assume the depth of the water is a sinusoidal function of time with a period of half a lunar day, which is about 12 hours and 24 minutes. At what time on that Labor Day does the first low tide appear? So before we can answer that, we need to set up our sinusoidal function. So from what you found in the notes, there's a way to construct your sinusoidal model to give you the general shape. What you have to start with is which one works best. We have a positive cosine, a negative cosine, a positive sine, and a negative sine. So what you have to ask yourself is the values you're looking at, do they have a maximum and a minimum, or is what you're looking at halfway between the min and the max, or the max and the min? What part of the sinusoidal function are you working with? So with a tide, we're working with a cosine function, because tides definitely have a high and a low. And because it is a tide, you can start counting at high tide or low tide. We're going to use a positive cosine function. So our function is going to be f of t equals a times cosine of b times t minus capital T, and then we have a plus c here. So we have to find a, b, and c. Well, the nice thing is that we can find the amplitude because we need the maximum and minimum values as well as the vertical shift. Those we can find pretty easily. Let's start first with the period because it is given to us. We're told that the period is half a lunar day, which is 12.24 hours. So we can find P. We have to convert the 24 minutes into hours. So we're going to take 24, divide that by 60. And when we do that, we get 0.4. So our period is going to be 12.4 hours. So we do have that. And now the next thing we can find is B, because the B in the function is defined as 2 pi over P. So we're going to get 2 pi over 12.4, which is going to give us pi over 6.2. Now we have to find, as I was saying before, the maximum height of the water and the minimum height, and then we can find our amplitude and our vertical shift. So that is also given. We're told that a high tide occurs at 7:12 a.m. and that the water is 11 feet deep. Then we're also told that low tide has happened and we have 7 feet there. So what we have is we have a maximum value of 11 feet and a minimum value of 7 feet. So now A is defined as taking your capital M minus your little m and dividing by 2. So we're going to have 11 minus 7 over 2, which is 2. Then our vertical shift is found by adding our max and our min and dividing by 2. So we're going to have 11 plus 7 over 2, so we get 9. So now we can write our function because we have all the values for it. So our f of t is going to be 2 times the cosine of pi over 6.2 times t minus, and the time we're going to use here is the 7:12 a.m. So if I convert that into hours as well, we're going to get 7.2, and then we have our plus 9 here. So now we can finally answer part A, which is at what time on Labor Day does the first low tide occur? So all we have to do at this point is take this equation and put it in our graphing calculator. So I'm using the 84 because I like that there's a big display screen to see. And you can see I have our equation here, and I set the window like this. There's 24 hours in a day, so 0 to 24. And I'm just going to let the whole day play out by the hour. And then the water is never going to go below sea level because even at low tides it's 7 feet. And at high tide it's 11. So I just picked 12 as a maximum because that's the highest the water is going to be during this Labor Day is 11 feet. So now when I look at my graph, it's going to be this cosine function. And what we have to do is we have to find the first low tide, so the first minimum of the day. So I'm going to do second trace, and I'm going to choose minimum, number 3. And I want to make sure that I'm not at that minimum where I'm close to. That's the one they talked about in the problem that occurs at, what's the time? 1:24 p.m. I want to go clear over here and get the one that happened as close to midnight as possible, because that's when the day started. So I'm going to make sure I'm a little past it, to the left of it. I hit enter. Then I move a little to the right of it and hit enter. And then the calculator asks us to guess, but I'm just going to hit enter. And it should give me the lowest value in between, which is almost exactly 1 hour. So 1 hour after midnight is going to be 1 a.m. So the answer to part A is the first low tide happens at 1 a.m. in the morning. Okay, so now part B says, what is the approximate depth of the water at 4 a.m.? So we can answer this again on our graphing calculator. And now what we have to do is, since 4 a.m. is a time, we can just hit trace and just substitute 4 and hit enter, and it'll take us right to that point. So we can see at the bottom of our screen that it was 8.89 feet, or 8.9 feet deep almost. So we can put that as the answer to part B. So at 4 a.m., the water was 8.9 feet deep. And then finally, part C has 2 parts. It says, part B has 2 parts. 4 a.m. and the second part, which I forgot to type there, was 9 p.m. So at 9 p.m. So we can go back to our graph and just type in, now remember 9 p.m. is going to be 12 plus 9. So that's going to be 21 hours have passed. So we can just type in 21 while we're in the trace feature. It'll take us right there. And you can see it's 10.52 feet. So the answer to this part is going to be 10.52 feet. Okay, and then finally, it says, what was the first time on Labor Day that the water was 9 feet deep? So what we can do is we can look at our graphing calculator and go clear back over to the beginning. So I'll just type 0 in, and you can see we're at 7.24. And I'm just going to trace along here and try to see when's the first time that my Y value, or the depth of the water, is 9 feet. So it's somewhere in between 4 and 4.18. So let me just try typing in 4.1 and see what I get. Oh, and there it's exactly 9. So that's the answer I want. So it happens at 4.1 hours after midnight. So changing 0.1 into minutes, to multiply that times 60, you get 6. So the time's going to be 4:06 a.m. And that's how you do an ebb and flow problem.